Hello and welcome to the first episode of Library of the Week. Today we will be talking about Pandas. It is a Python library mostly used for data science and data analysis. In the description of this video, you will find a link to a Medium article I wrote. So why did I write and why am I doing this video about Pandas? Why use Pandas? Basically, Pandas is a necessity if you are doing data analysis or data science with Python. It is the go-to library to work with data. Any data processing that you will do in Python, unless you are working with big data or if you're building pipelines, but for data analysis you will very likely be using this library, and it integrates very well with other data visualization libraries or statistical analysis libraries, etc. In the Medium article, you will find all the links to the official documentation and to the GitHub repo used for the Pandas project, as well as the PyPy's page, so you can have a lot of official information there. And now let's have a quick overview of the main statistics about Pandas. So these are to date of July 12th of 2023, and we are in 2.0.3 version of Pandas. There is 118 million downloads on PIP and almost 4 million Conda downloads. The first release of Pandas is from December 25, 2009, so this is a very old library for Python standards, and the latest release is from June 2022. There are 6 dependencies. The most famous one would be NumPy, and on GitHub the project has 38, almost 39,000 stars, 16,000 forks, over 1,000 watchers, and over 1,000 contributors. The source rank on libraries.io is 30, so this is a very reliable library, no problem with that. The project is sponsored by NumFocus, which is a non-profit organization that is itself sponsored by a lot of big corporations. You can also donate if you want. NumFocus sponsors many other well-known projects. Just to name a few, you have the Julia programming language, Conda Forge, or other Python libraries such as Matplotlib or SciPy. Pandas has a huge community. There is thousands of contributors, and this huge community leads to a lot of documentation and resources for you to use. On the official documentation you have the Pandas cookbook, which is kind of a how-to guide to Pandas. The community has also a fantastic blog. In this blog you will find kind of a lot of advanced topics about Pandas, and there is over 280,000 questions opened on Stack Overflow. So what are the pros and cons of Pandas? In the pro section, it is a very robust and reliable library. It benefits from years and years of development and, as we said before, from a huge community. So this makes it a very, very well documented project, and anything you want to do with Pandas, there is 99% of chances that somebody else did it before and that you will find the answer when you Google it, either on Stack Overflow or in whatever other forum, and even on ChatGPT nowadays, right? So the main limitation of Pandas comes when we work with large datasets. Things like big data are not properly handled by this library. Right now, a library that is becoming very popular and people talk a lot about is Polars as an alternative, a faster alternative to Pandas. We will probably be talking about this soon, so subscribe to this channel and stay tuned. And now we're going to see a few practical examples on how to use Pandas. So now we have a Jupyter Lab environment and we're going to test Pandas. We're going to do 2 examples, a very easy one so you can see what can be done with Pandas, and a more complex one. Not necessarily more complicated, but more complete. So the first thing we're going to do is we're going to import the library. For that we do import pandas as PD. This is the most common way to do it. And next we're going to import the data. There are many ways to import data to pandas. In this case, we're going to use the iris dataset from the sklearn library. Pandas does not provide a test dataset that allows us to do test and learning, so this is why we are importing it from another very well-known library. sklearn is used for machine learning. Now this is not the scope of this video to talk about sklearn, and you need to install it if you want to follow this and do what I'm doing, but I'm not gonna be talking about this library at all. Just know that when we do this code, we're creating a df-iris data frame, and it's going to have a structure that we're going to see right now. So as you can see, the df-iris data frame is a table with information about sepal length and width, and petal length and width for different plants. This is a very famous dataset to test computer science libraries, especially for machine learning and data analysis, data manipulation, and data visualization. If we use the .head method, we see that it will only display the first 5 rows of the data frame. This can actually be changed. We can display the 10 first rows or the 2 first rows. Let's keep the default, that is 5. And for our simple example, we're going to calculate the descriptive statistics of this data frame and create a new data frame with these descriptive statistics. So a first function that we are going to see is the max method. When we use the .max method with the data frame that we created, we create a pandas series that will hold for each column of the data frame the maximum value for that column or for that pandas series, because in pandas every column is a pandas series and the whole table is a data frame. And now, in order to create a new data frame with the summary statistics for the df-iris data frame, we can do the following operation. So in this case, we use the pd.dataframe to create a new data frame, and as you can see, we pass a dictionary, a Python dictionary, to create this data frame. Max, min, and average are strings of characters, and they are keys to this dictionary, and they will become the columns of the new data frame we are creating, which is called df statistic iris. df-iris.max, .min, and .min mean are 3 different methods that get the maximum value, the minimum value, and the average value for each column of the df-iris data frame. They all will have the same index, they all will deliver pandas series type of values, and they will always have have the same type of, well, not the same index, because they are referring to the same df-iris. And when we do this, let's execute it. This creates this new data frame, and let's see what happened here. Well, I can use .head, and as you can see, we have a new data frame with sepal length, sepal width, petal length, and petal width as indexes, and max, min, and average as column names and the respective values for each. Let's now do a more complex example, and let's do a complete data analysis, very simplified complete data analysis with pandas, only using pandas. So a first thing we're going to do, just to show you that this can be done, is add a new column to the pandas data frame. So in this case, we're using the df-iris dataset again, and we're adding a new column called species. We're using the sklearn object that we loaded at the very beginning. If you use this syntax, it will be adding a new column to the iris dataset with, for each row, the name of the species of plants that has the sepal length, the width, and the petal length and width. And now we're going to see how this looks. And you see here I use the dfiris.head to show you the first 5 rows of this data frame. I can also use .tail, and this will show you the last rows of the data set. And you see here the last species in this table are of the species Virginica. So one thing that Pandas allows us to do, let's see an example right now, is create charts. The following code will create a scatter plot. So you see we have the data frame .plot.scatter, and in parameters to this scatter function we have to pass the x and the y values for the chart. C, which is not a mandatory parameter, but this will be used to color the points, and color map. So think of color map as a color palette. In this case, the name of the color palette is Viridis. There is a ton of them, you can check in the documentation, and let's see how this looks. Okay, looks great. It is good to know that Pandas is not primarily a data visualization library. It offers data visualization functions that are based on matplotlib, so you will need to install matplotlib. It is important to know that you need to install it, but you don't need to import it, because Pandas will automatically call it for you when you use this syntax. So as you can see here, we are using petal length, which is a continuous variable, to color the different points of our scatter plot. It would be better, in my opinion, to break this chart by species, which is a categorical value. And the problem, if we do that, let's see it right now, is that this syntax will give us an error. Pandas is really not a library meant for data visualization. You can use it to do very quick visuals when you're doing a quick analysis, so for that it's good, and it comes in handy. Instead of having to import a lot of different libraries, to know that it is somehow versatile and that you can somehow use it for a lot of different things. But this is not what Pandas excels at. I still wanted to show you that you can actually use Pandas for quick data visualization, because in the other hand it is very quick, right, to do this syntax. The next thing we're going to do is we are going to create some calculated columns. So just like before we added a new column to the dataset with the species, we can add new columns based on the values of other columns. See, in the following line of code, we are adding a new column to the dfiris dataset. It will be the sepal ratio, and it will be done by dividing the sepal length by the sepal width for each line of the data frame. So we execute this code, and let's see how the data frame looks now. And as you can see, the sepal ratio has been added. And now let's add some more calculated columns to this data frame. So I added the petal ratio, the sepal area, and the petal area to the dfiris dataset. And let's see how this looks now. As you can see, the petal ratio, the sepal area, and the petal area are now added to the data frame as well. So next thing we're going to do is we are going to filter this data frame. We are creating a new data frame which is called df versicolor virginica, and we are creating it by filtering the df iris data frame. So basically df versicolor virginica will be a subset of the df iris data frame, and in order to filter this we are using two different logical operations. The df iris species double equal versicolor. This is a double equal because we are evaluating and we are not assigning. This is, I would say, basic Python syntax. Let's see what this does real quick. If I execute only this part of the code, as you can see, this creates a Pandas series, which a list of Boolean values, so true or false. It will be true when the line of the Pandas data frame corresponds to the species versicolor, and it will be the same for the species Virginica. So what we are doing is we are keeping only the lines of the DF-Iris dataset when DF-Iris species is versicolor or when the DF-Iris species is Virginica. Notice that in Pandas, this is not intuitive when you are used to Python in general. The logical OR operator is a pipe. This is actually something you find in other computer languages, but in Python, in pure Python, it's usually you type OR. So here is the pipe. Next, we are going to do a group by operation in Pandas. So I just realized that we did not execute this previous line of code. So I just did, and we did not inspect the result of the previous data frame. So here, as you can see, we have versicolor, Virginica, and we do not have Setosa anymore. And now let's really come back to our group by operation. We are going to create a new data frame. In this case, it's called df mean ratios. We are going to start from the data frame which was created, the df versicolor Virginica, and we're going to use the group by method. Group by will group the data frame by, in this case by species, and we can extend this by using the AGG function. So this means aggregate or aggregation, and as arguments to this function we pass a Python dictionary where as keys we use columns of the data frame, in this case the sepal ratio and the petal ratio, and as values we use a function that we want to use for the aggregation. In this case we're going to use the mean M-E-A-N. Mean, M-I-N, or max, or median are also values that would work. Let's keep this out for now, this reset index. I want to show you what I can do with this first. So if I execute this, let's see the result. So you see this created an aggregated data frame. We have versicolor and Virginica that are now indexes of this data frame, and sepal ratio and petal ratio are columns. Now what we want to do is, or what we want to have, is a data frame where the species is actually one more column of the data frame. We don't want this to be an index, because we cannot work with index like we work with columns. And in order to do that, we use this reset index function. When we use this in place equal true, what it means is that the df mean ratios will change, if you wish, when we apply this reset index function. If I do not put in place equal true, let's do that first. This is the result we want. The species now became a column, but if I come back to checking df mean ratios, how it looks like, it still looks like species is not a column, it is the index instead. If I put in place equal true, and now I check how the data frame looks, see, the results are changed. This is a way to do it. Another way to do it would have been to reassign the value of the data frame using the function. Now, just to finish, we are going to make another bar plot, just because I like plotting results. Everybody does, right? I use the plot function, and in this case we're going to do a bar plot, so I use the bar function. I pass the X and Y values. So X will be the species, and Y, in this case, I'm going to pass a list of values, so I want to plot at the same time the sepal and the petal ratio. And let's see how this looks. So as you can see, the X shows the species, versicolor and virginica. We filtered the setosa out in our previous steps, and in Y we have the sepal and the petal ratio. They both have the same unit and they are colored differently. So sepal ratio is in blue and petal ratio is in orange. This is not the best possible visualization you can do, but Pandas offers a quick way to visualize data, and that is always great to have, and I would take it anytime. So that was it for today. I hope you liked this video. Do not hesitate to comment and ask me to review any library, any Python library that you would want. Please like it, subscribe to this channel, and I hope to see you soon. Bye.